Hey everyone, so today we're going to go over how to add vectors. Now before we begin, we need to know that a vector is made up of magnitude and direction. Now that we have that in mind, let's go over the first example. So say you have a vector going 75 newtons to the right or east, and then you add 100 newtons to the right or east. The resultant vector will be 175 newtons east, simply because we add the two vectors since they're going in the same direction. Now let's try the next problem. Say you have a vector that is 100 newtons going east, and you add to it 35 newtons going west. The resultant vector will be 65 newtons going east, because you subtract 35 from 100 since 100 is bigger. So straightforward so far. For the third problem, say we have a vector that's 250 newtons going east and 300 newtons going west. Now try this on your own, pause the video and try it on your own, but when you come back you'll see that the answer, the resultant vector, is 50 newtons going west, because you subtract 250 from 300 since 300 is the bigger number, and they're going in opposite directions. Now for the next problem, feel free to try this on your own. Say you have say you have a vector going 25 newtons to the west, and then you have a vector 50 newtons going east. Now the answer to this is going to be, the resultant vector will be 25 newtons going east, because 50 is larger than 25, and therefore when you subtract 25 from 50, since they're going in opposite directions, you still have the 25 going east. Now let's try something a little different. Let's go, say you have a vector going 50 newtons east, and then you add to it a vector going 75 newtons north. What's the resultant sum vector? Now there's a process to this. The resultant sum vector is going to be the hypotenuse of this right angle triangle. And to figure this out, we need to know Pythagoras' theorem, which is a squared plus b squared is equal to c squared. And now let's make 50a and let's make 75b. When we sub it in, we go 50 squared plus 75 squared, which is equal to 8,125. And that's our c value. Now we don't want the c squared, that's our c squared value, and we don't want c squared, we want the c value. So to get that, we simply have to square root it. The square root of 8,125 is equal to 90.14 newtons. 90.14 newtons. But then we still have the angle that we can solve for. Now for the other problems earlier, the angle was 0 because they were all on the same planar field. But for this, they aren't, so we can actually solve the angle. And to do that, we have to use the inverse tangent function. So theta is equal to inverse tangent b over a, opposite over adjacent. theta is equal to inverse tangent 75 over 50. Theta is equal to 56.31 degrees. And that's the properties of the resultant sum vector. It's 90.14 newtons at 56.31 degrees above the horizontal planar field. Let's try the next problem. We have a vector going 60 newtons east, followed by a vector going 40 newtons south. The resultant sum vector is going to be the hypotenuse. And feel free to try this example on your own, as it's very similar to the previous one. Pause the video and try it on your own. But when you come back, a squared plus b squared is equal to c squared. Let's make 60a. Let's make 40b. 60 squared plus 40 squared is equal to 5200. C is equal to the square root of 5200. C is equal to 72.1 newtons. 72.1 newtons. And then the theta that's over here is once again equal to the inverse tangent function, opposite over adjacent. Theta is equal to inverse tangent b over a. Theta is equal to inverse tangent 40 newtons over 60 newtons. Theta is equal to 33.7 degrees. So the resultant sum vector is 72.1 newtons, 33.7 degrees below the horizontal planar field.